Hello, everyone. Just going to run through a few things here with simplifying radicals real quick. This first one here says, use the product rule to simplify the following expression. We need to talk about a couple of these. So when you look at, just first of all, some terminology, um, most of these lessons show this symbol. This is called a radical symbol. Okay, so what I typically I would refer to this as radical 363x squared, is how I would say that. I would not say that this is the square root of 363x squared. I just say radical. When we change the number here, which will happen from time to time, this is what's called the index. Okay, as my pen catches up. This is called the index, and the number, the entire product that's under here, is called the radicand. So this is terminology that may be thrown about in your math textbooks or Math Excel. That's what we're going to be using for the homework. So understand this is called the index. When there is no index written, it's assumed that this is a square root. I'm still going to refer to it as a radical, and the number that is underneath here is called the radicand. Now, as far as the product rule is concerned, the product rule pretty simply just states that if you have the square root of a product, that is the same thing as the product of two square roots. Okay. And it works both ways. Sometimes it benefits us to multiply two radicals together to create one, and then take one and separate it into a product, just so long as these radicals have the same index. Okay, so when this says use the product rule to simplify the following expression, it always helps when you're looking at these problems to know in this case, because it's a square root, it helps to know your perfect squares, as many as you possibly can. And there's really no way of getting around it other than just memorizing them as high as you can. Okay. And we're talking about these numbers 1, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, dot, 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 as high as you can go. Okay. 363 is not one of these perfect squares. Okay. You get up to, I don't even know all of mine, to be honest, but I believe 20, let's say, I know that 17 squared is 289, and I believe that 18 squared is 324. 19 squared is definitely not 363. I'm not exactly sure what that is. Okay. So 363 doesn't fall into that category. So when it comes to simplifying using the product rule, what they're saying is you can break down this product into a product of radicals and taking each one of these separately. So what we typically do is we take any variable powers like this, and we give them their own radical over here. And then we try to break down 363 into a product of the largest perfect square factor that's contained here. Okay, and it's not obvious if you don't know all of your perfect squares, and if your mental math is not that great, this is when you'd have to start checking this. But 363 is divisible by 3, and it just so happens that when we divide 363 by 3, we get 121. And 121 is a perfect square, right? 121 is 11 squared. So when we take the square root of 121, we get 11. We can't take the square root of 3, so we have just the square root of 3. Now, here's where things get kind of strange. When we take the square root of something here, that a variable that's raised to a power, right? We've talked, at this point, you may have seen some work on writing radicals as fractional exponents, okay? Now, clearly, the square root of something squared, it's just going to be that value of x, right? But a different way to think about this for when the indices start to change, or when this power is something bigger than 2, is that a square root can be written as a fractional exponent, where whatever the index of the radical is, that's what goes on the bottom here. So because this is a square root, I put a 2 here. If we were dealing with a problem that had a cubed root, I'd put a 3 down here. Okay, and you should know your exponent rules, that powers of powers get multiplied. So this becomes x to the 2 over 2 power, which is just x to the first, right? Which is x to the first, which is x. So this is a really long-winded explanation of why the square root of x squared is equal to x. Now, sometimes some books, some programs get very technical with this. When you take the square root of a number and when that's an unknown value, like a variable, okay, they want you to say this is the absolute value of x. So whatever the square root of this is, we're only including the positive value. And then we plop all these numbers back together. So we have 11. Anything that's not under a radical can be pushed together. So this becomes 11 times the absolute value of x times the square root of 3. And this would be our final answer for the simplified form of that. So the product rule, taking a product, separating it into factors, trying to find that the largest perfect square factor that you can to take that square root and then pushing everything back together again.